the devil is in the details. That's another thing that I emphasize. There are so many variables that have a bearing on the ultimate outcome. If you're looking again in the area of diagnosis, if you're looking at a product, what are all the input variables that affect the repeatability, the reliability of the product? When you're manufacturing, what's the chemical process, for example, to make the assay? Factors like temperature, factors like concentration, factors like flow rates, pressures in certain instances. So figuring out that process window and establishing a stable process setting so that the output is consistent. On the back end, anticipating where these products are going to be used, right? If it's a diagnostic, again, an assay, what's the shelf life? How does it behave, not just in a lab at 24 degrees centigrade in air conditioning and controlled humidity, but in the back of a truck at 45 degrees centigrade, at minus 20 degrees centigrade, at plus 50 degrees potentially. And it's not to say that you have to always design it for all those use cases, but you ensure that you capture enough use cases and then specify that it can be used only under those constraints. But you need to know these things and understand and characterize the product early on so that you don't end up with a situation that the customer is telling you that you have a problem with your product. That's risk that you can't afford, especially as a startup.